This is the analysis section of the lab. And for this section, what we're going to be doing is just kind of reviewing our data and then kind of looking into and making sure we understand why a precipitate was formed in some of the reactions. So the first section here, I'll summarize this a little bit for you. It's just kind of reminding you what it means to be soluble and what it means to be insoluble. So here we have water. Water is a polar substance. That means that it has partial negative and partial positive ends. So my oxygen end, the red molecule, has a partially negative charge, and the two hydrogen atoms both have partially positive charges. Because of this, because it's very polar, it can actually attract other positive and negative charges in other ionic compounds. So if I add salt in with water, remember salt is an ionic compound, so it creates this crystal lattice structure of positive and negative charges. So my blue molecules have my positive ions, the green particles are my negative ions. So what happens is when this is mixed with water, the water molecules can actually kind of wedge themselves in between these positive and negative ions. The partial positive ends of the water molecule where the hydrogens are attracted to the negative ions, and the partial negative ends of oxygen are attracted to the positive ions. This is how salt is able to dissolve, because it can actually dissociate or break apart into smaller or individual ions instead of being this large lattice structure. So that's what we're talking about when we're saying something is soluble and insoluble. And remember, when we say dissociate, that just means that it breaks apart into smaller particles. For this next section, we're going to start analyzing some of our lab results. This paragraph, these bullets here kind of summarize the first reaction that you saw, which was with silver nitrate and sodium phosphate. Both of these are aqueous substances. Remember, aqueous, or the AQ, means that it's just dissolved in water. That's all we mean. The water does not actually participate in the reaction. It just is kind of like the background where the reaction takes place. So because these both have an AQ, that means they're soluble substances. Once these two substances are mixed together, they form two different products. The products are because a double displacement or double replacement reaction has occurred. And you notice that in this reaction, you did have a cloudy, it turned cloudy, and that was because there was a solid precipitate that was formed. And the solid precipitate is actually the silver phosphate. And I know that it's the silver phosphate because I can just look at my solubility rules and I can determine that I just find the rule about phosphates. And if you notice, there's an exception for silver that says that it is insoluble. Most silver substances are insoluble, which means that the second substance, the sodium nitrate, remember nitrates are always soluble is what our rules say. That's why I have an AQ at the end, because it's still dissolved in the water. It's not really participating in the reaction at all. As we go on through this, through the lab analysis section, remember, you're always going to use these symbols after our substances. So anytime you have a precipitate that is insoluble, we're going to use the symbol S. Anytime we have an AQ, we are going to, or anytime we have a substance that is soluble, we're going to designate that using the AQ, aqueous symbol. So for here, these couple questions for number one, you're just going to kind of make some generalizations from your data table. So if we look at, and I've given you some hints, so most sodium compounds if you go up to your data table here, if you notice, almost all of my starting solutions are sodium compounds. So what could you say? Are these soluble substances or are they insoluble substances? Think about what you started with. In the video, you're starting with liquid droppers. So that's kind of the same thing for this one and this one. Our starting substances going down our groups here, those are all nitrates, okay? So when we get to the next couple questions where it's kind of wanting you to look at most silver compounds, hydroxide compounds, I'm giving you some hints on where to look. So for silver, we're just going to look across the first row. For hydroxide, we're going to look down column 6. So what I mean by that is, for the first one, for silver, what kind of generalizations can you make as you move across this row? Did you notice that a lot of your substances were cloudy or forming a precipitate, which means that it's an insoluble substance? Or did you notice that they were mostly soluble? When we're going down this hydroxide column for the next question, what are some patterns that you noticed? Did you notice that many of them were soluble? Or did you see a cloudy precipitate formed in lots of those reactions? So again, there's always exceptions. So I'm not asking for, did every single cell have the same thing? But you're just kind of looking, did you see a majority? What's the majority reaction? What does that look like? And that's the generalization statement that you're saying. So here's an example. So you're saying something like, this one says most carbonate subcompounds are, you would say, insoluble in water, right? Because precipitates are insoluble. And then if you do see some exceptions, which you might very well see, then you could say except for whichever that you saw, okay? Number 2, you're just going to compare those generalizations to the actual solubility rules that we've been looking at over the past 2 days. So do you see any similarities, or maybe you found some differences based on your lab data? Okay, and then number 3, I just want you to give me 3 different substances that produced a precipitate. So tell me the full substance that would... the two different reactants that produce that precipitate when it's mixed, okay? Lastly, we have some post-lab questions. This is just getting some practice predicting the products and determining which one is soluble based on your solubility rules and which one is the precipitate. This is the same thing. These 4 questions are the exact same thing as that I did at the very beginning of the lab. So if you need to go back and review that video to help refresh your memory on how to do this, remember you can separate the 2 reactants into their ions, then you're swapping the cations. Don't forget, you're also going to balance the equation when you're done. And in this case, we're going to write the word equation. Let's get some practice writing and seeing these word equations. So this is going to kind of go back to those ionic compounds when we were naming those. So I'll do this first one for you just to kind of refresh your memory. So remember, when I'm naming ionic compounds, the first rule is I always name my first substance. So CO is cobalt, okay? And then I name my second substance. If it's a polyatomic, I just keep the name. If it is a standard, a single element, like this second substance would be, then I change the ending to "ide." The last thing I have to do is double check to make sure that my cation is not a transition metal. So if I look at my periodic table, the reference sheet with all the charges, I'll see that cobalt is a transition metal and it has multiple charges, which means that I have to put my charge in Roman numerals in parentheses. And I know what my charge is because of this number down here. Remember, that was the original charge that was crisscrossed. So I'm just going to put a Roman numeral 2 for the 2 plus charge. The second substance is sodium. Sodium is not a transition metal. It only has one option for a charge, so I do not need any Roman numerals. And then this, I would change iodine to iodide. Okay, so that is my reactants written out in the word equation. So once you predict your products, then you would write out your products names. Okay, just like I did there. So you're going to do that for each of these as well.